security into your workflow. A few notes of housekeeping to make sure everyone has the best experience today. Join the conversation, right? So today's session is all about Q&A on advanced security. So feel free to ask away in the chat. Either Kevin or Isaac will be responding. For your optimal viewing experience, please be sure to join us from a desktop. We recommend using Google Chrome or Safari. Firefox works as well, but with all of them, please make sure that you're updated to the most current version. Book a meeting. You're going to hear a lot of interesting things today. So if you want to chat with someone on our team, please hit the book a meeting button on your top corner. So before we kick things off, let's meet our speakers for today. If you were here yesterday, you had a chance to meet Isaac Cohen. Isaac is a principal architect here at GitHub, and today he'll be giving you a step-by-step demo on features like code scanning and secret scanning, as well as showing you how you can build security right into your developer workflow. To help Isaac out today, we've got Kevin Allwell. Kevin is one of our solutions engineers here at GitHub. Kevin is a security pro, and he'll be guiding us through some of the demo as well. Once again, please don't forget to ask questions and post comments in the chat. We'd love to hear from you. Kevin and Isaac will be addressing these throughout the demo. So with that, I'm going to pass it over to Isaac and Kevin.
Thank you so much, Sean. I'm so excited to be talking to you all today. Again, my name is Isaac Cohen. I'm a field architect here with GitHub, specializing in security and GitHub Advanced Security. Been with GitHub for the past 4 years. Used to work at JPMorgan Chase, ran DevSecOps over there. Kevin, would you like to introduce yourself?
Sure. Hey, everyone. Kevin Allwell here, solutions engineer at GitHub. Special shout out to my friends in Minnesota, special friends there. And of course, Mr. James, I see you in the chat. So hello, everyone, and looking forward to this conversation.
Yeah, so today we're going to be very much focusing on GitHub Advanced Security. We're going to go through a deep dive demo of what GitHub Advanced Security looks like. Feel free to utilize the chat. So I'm going to be looking at the chat throughout this demo. If you have any questions, feel free to post over there. Excited to answer them as they come in. Okay, let's get started. So when I think about the security space, I think about some of the problems that we have today. And I know we've discussed some things yesterday, but let's set this up. So the amount of lines of code, obviously increases over time, right? Like if you're coding, for most coding projects, the lines of code increase. Along with that, what we found from the GitHub data science team is that if you look at the purple line over here, the commits that mention vulnerabilities increase as well, right? So this sort of makes sense. The scary thing for me, though, is the red line. The red line saying that security threats are continuing to increase at a linear pace with those other two lines. What that means is that even though developers know there are more vulnerabilities coming in, right? Because we see the commits mentioning vulnerabilities, we know that they are aware of the risks of vulnerabilities. We still don't see a real change in the security market, right? Like the security threats are still increasing, nevertheless. Well, let's couple that with the fact that flaws in applications are the number one attack vector for breaches, right? So it's not the network vulnerabilities, it's not phishing, which those are super, super important. Obviously, you want defense in depth, in layers. But the number one attack vector is still applications, is still security issues, flaws in your application. Let's also think about the DevSecOps divide. So when I think about the developer environment, I go back a couple of years to when I was developing on a day-to-day basis, I coded, I went through CI, then we went through the deployment process. But it was only at that point that we started to engage the security teams. Now, I'll be honest, a lot of times we treat security as a checkbox experience, right? Like check off the boxes and you're fine. Naturally, I didn't want to engage the security team as much because they're just going to slow me down to production. So what happened was security would come in really right before prod, right? In pre-prod. Security comes in, they look over all of these things, and they say, and then they print you out a list of vulnerabilities that you may have seen. And then I sort of had this choice, right? Like, is this vulnerability high enough that we should actually stop a deployment? That's not a good choice to be in. That's not a good situation to be in. And then of course, right, like, after security comes in, ops comes in. So we need to fix this, right? Like, we know all of these problems. We've discussed them throughout this entire week. This DevSecOps divide, the fact that Dev doesn't necessarily talk to Sec as much, the fact that we're all using different tools, and then you throw ops into the mix, it confuses everybody. So this is where GitHub comes into play. GitHub delivers a complete application security solution. And there are a couple of key tenets that GitHub uses in all the things that we design. Number one, being developer first, right? Like, everything that GitHub tries to do is tries to make it as developer first as possible. If you want to fix issues faster, you need to rely on your developers to actually fix those flaws, to actually fix those security vulnerabilities, which is why we very much focus on the developers' lives. Number two, native, right? Like, we build things natively in as part of the GitHub solution. Developers wake up and they open up their GitHub, and then when they go to sleep, they still have their GitHub open, right? Like, GitHub is that central location where developers live, where the home of software and the home of open source live. So everything that we build becomes native into the GitHub application. And then finally, we try to automate as much as possible. And I believe that there is a lot that can be automated in the security space. So when I think about GitHub Advanced Security, I think about these three different pillars that we focus on. One is the supply chain, right? So GitHub secures your complete software lifecycle. One is the supply chain, where we're looking at your open source dependencies and giving you alerts. Do you have any vulnerabilities associated with those dependencies, right? Because all of this lives in the GitHub, because of all of open source lives in GitHub, it's very easy for us to supply that information to you for your specific projects. The second main pillar is code. This is where we go very deep into your code in order to figure out, do you have a SQL injection vulnerability? Do you have something like cross-site scripting, right? Like code level detection, as well as our ability to search for secrets, right? Like, looking for secrets is a huge issue in the industry. We'll talk about that as well. The third pillar is the development lifecycle that we focus on, right? This is starting to get higher level insights. So, where the individual developer is very focused on the repository level, let's try and derive things across the entire organization or across your entire enterprise. So these three pillars comprise of the GitHub Advanced Security solution. I'm going to focus on code. I'll switch it over to supply chain for Kevin, and then we'll come back to the development lifecycle. All right, let's get started. So code. As I mentioned before, right, GitHub tries to build security into the GitHub native platform as much as possible. And so this is why we ventured down the code area. What code does is it searches for the OWASP 10, SANS 25, right? Like your SAST level scans happen within GitHub, but also you can start to surface that information directly within the UI within GitHub. We're going to get back to this, right? Like, I'm going to show this to you live. But before we go there, I'd like to discuss some of the technology underlying everything that we do. So for those who have tried out GitHub Advanced Security or have public open source projects have tried out code scanning, you may hear this term CodeQL. CodeQL is the engine behind GitHub code scanning that actually runs the nitty-gritties, right? Like, this is what we use in order to find vulnerabilities, find flaws within your application logic. CodeQL is a revolutionary semantic code engine, right? It's advanced code and analysis engine. It was developed through 13 years of research from Oxford University. This is the language that we use in order to find vulnerabilities. Now, what's interesting about CodeQL is that it's not just like a regex type pattern that we're looking for things in files. No, we're able to understand the logic of your code and traverse from source to sink the data flow. Now, because we're able to traverse and understand how your data flows through your application, we're then able to find these vulnerabilities, like a SQL injection attack, right? A SQL injection vulnerability. Let's think about what it means to be a SQL injection vulnerability. You're pulling information from an untrusted source, maybe a REST API or something like that, and that's then flowing through many methods and many different files, finally to an unsafe sink. Maybe you're executing a database query, but you've never sanitized anything in between, right? That's the basics of a SQL injection vulnerability. This is what CodeQL allows you to do. CodeQL allows you to traverse information, to traverse data from source to sink. That's a very powerful engine. It also allows you to create your own sorts of patterns that you should be able to look for. That's a little bit about the technology behind this. CodeQL, we did open source all of these CodeQL queries. I will show you them. But it's important to note that there are a certain subset of queries that are developed by GitHub themselves, right? So this is where we're looking for the CWEs and the OAuth top 10s and the SANS 25, right? These are the queries that we're developing. But there's also a layer, because we've open sourced CodeQL, we have community-powered queries as well. What's interesting about that is security can't just be done by GitHub. We believe in the open source, and we believe in the network effect of allowing security to be done by other folks as well. So you'll have the Microsoft and the Googles and the Ubers of the world create their own queries and then actually contribute it back to GitHub. And a great example of this was actually this blog article you may have seen on February 25th, right? Microsoft open sources CodeQL queries used to hunt for Solorigate activity. So Microsoft actually uses CodeQL. They were looking for Solorigate activity. They found, they looked throughout in order to find it. They created their own queries, and then they actually open sourced it back to us. And that, I think, speaks to the power of CodeQL in the fact that it's not just GitHub who's solving these security issues. It's also we're now giving that ability for the community as well. Let's go to demo. Let's look at what this looks like. Okay, so I'm a developer. I'm working in this repository conveniently named Demo Vulnerabilities GAZ. I open up a pull request, and imagine that I'm typing and I'm creating a PR, and I want to merge that PR now. I want to merge that pull request. Well, scrolling down, I immediately see code scanning results, CodeQL failed, right? So there's a big X saying that there's a new error that I've introduced over here. Well, let me learn more about this. Why is there an X? So I'm going to click on details. And very quickly, I see that there's a query built from user-controlled sources. Well, what does that actually mean, right? Like, I'm a developer. I may not know what a query built from user-controlled sources is. I'm going to click on Show More Details. And this is going to take me, let me increase. This is going to give me an explanation of exactly what vulnerability I actually found. So a couple of pieces of information I get right away. One is query built from user-controlled sources, right? Like this is building a SQL or Java persistence query from a user-controlled source that is vulnerable to malicious code by a user. I can see that this issue is currently open. It's an error, and it's connected to a number of CWEs, CWE 89, 564, as well as this is specifically a security issue, right? Like we also can find quality issues. This is specifically a security issue. Scrolling down, I can also, remember, like as a developer, I may not know what this means. So I get immediately a recommendation, right? Like this is how you should solve this issue. Maybe a couple of examples as well, right? These are examples of bad versus good, right? Like this is immediately trying to train the developer of the issue that they're seeing and basic guidance of what to do over here. And then finally on the bottom, a reference to the other locations, like OWASP and Java tutorials, Java EE tutorials, to start to learn more about this. But as a developer, the main thing I want to know is, well, where is this actual vulnerability, right? Like, how did it manifest itself? And so that's where I can click on the Show Paths button. So clicking on that, this is going to show me that exact data flow from how it moved from source to sink. This also shows the power of CodeQL in the background, right? Like this is the type of analysis that we're really doing. So you can see over here that this is 4 steps. This happens to be a Java project, and it happens to be calling a REST API. So we can see that we're getting some data over here from a REST API, right? String name, string authorization. It's going through a couple of different methods, and finally ending up in an execute query, right? Where we're executing against the database. And we can see, of course, that this query might include code from user input without it ever being sanitized. Obviously, this is a huge issue, but look at how simple and how easy it is for me as a developer to figure out exactly where I need to put a sanitization point, right? Maybe between step 2 and step 3, I need to put a sanitizer over there and fix this issue. We're giving you that exact visualization within the GitHub native platform itself. A number of other things that I can do over here. Maybe this is a false positive. I can click on dismiss. Dismiss this as false positive, using test, won't fix. It's important to note that even when you dismiss a vulnerability, they never really go away. You're able to always see past vulnerabilities. And so this, I will click on the security tab, click on code scanning alerts, and this is going to show me all of my code scanning alerts that are currently open today, but also all of the code scanning alerts that were as well closed. It's important to note that, right? Like when a vulnerability is closed, we'll still be able to see that. We'll still get that full audit trail in order to see that later on as well. Okay, so we've gone through the basic flow of a developer. One last thing. Remember that CodeQL technology that I was talking to you about? Which query actually manifested in this vulnerability? Well, we can see that as well. So you can see that we used CodeQL, we used the rule of Java SQL injection, but now I can also click on View Source. And this is going to take me to the actual CodeQL query, the open source CodeQL query that we used in order to find this vulnerability. Now you can imagine if I wanted to modify this maybe for my own use, you can modify it. If I wanted to create a new vulnerability, all I have to do is PR, pull request against this repository. This gives folks a tremendous amount of control and flexibility. The other thing to note is that any SaaS tool only knows about the general frameworks. You may have a very specific framework in your company that we will never know about, and that will affect our false positive rate. Because CodeQL is the language and the queries are open, you can then create your own framework support within CodeQL, and thus that trains us as well. Like then you can run those framework queries private to yourself, right? Never share them with GitHub, but that at least gives CodeQL, the engine, the ability to understand that and weed out any of the false positives that you may see in the past. Okay, we've gone through code scanning. One other thing to note over here. This UI is not just available for CodeQL. If you have other tools that you may be using, maybe they are a linter or something like that, you can also integrate with the CodeQL, with the code scanning UI. And the way to do that is, as long as the tool supports the Serif standard, I can click on the security tab, and you'll notice I have CodeQL, but I also have a bunch of other tools as well, right? ESLint, Go Security Audit, HADOLint, et cetera, et cetera. So I can upload all of these results into the GitHub native UI and thus get much closer to the developer instead of them having to either run this manually or show this to them in some other UI that they don't use every single day. So we've gone through a number of things, right? Like we've gone through code scanning. One last thing on code scanning as well. So how do I actually get started? So I'm going to click on the security tab. In order to run code scanning, you need to run this as part of your build. The reason for that is we glean a lot of information from your build, if it's a compiled language, of course. We're looking at the class path. Everybody who uses the class path knows that if you modify anything in your class path, that could actually have significant effects to how your program is executed and what happens within your application. So we look at your build, and essentially I'm going to click on the code scanning alerts. I'm going to click on set up more code scanning tools. Over here, you can see a bunch of different tools that you can set up. I'm just going to click on CodeQL analysis. I'm going to set up that workflow. This opens up GitHub Actions workflow. And the basic idea is you need to initialize CodeQL before your build, and you need to analyze CodeQL after your build. I mean, that's really it, right? Like in between, you can stick your build, or you can also use auto build. If you're using another CI, like a Jenkins or anything like that, you can also use that as well. It's obviously very easy to do things in Actions because we have this all integrated as part of the platform. But if you are using another third-party CI, feel free to do that also. OK, we've gone through code scanning. There's another issue that we try to solve over here, and that is secret scanning. One of the big issues that we have today is, and this is a huge attack vector, is folks will accidentally leak their credentials or commit their credentials into a Git repository. This happens all too often. I've personally done it in the past where I have a dot file and accidentally gets released into a Git repository. We're now able to also scan for secrets within your private repositories as well. This is what we term as secret scanning. Secret scanning detects secrets from a number of different service providers, actually a whole bunch of service providers. We can see over here from AWS to GCP to Slack to Adafruit to Alibaba, really like 27 plus service providers. If you check in those keys, you should get notified very, very quickly from us directly within GitHub. You can see that as well over here, right? So if I click on the secret scanning alerts, I see Terraform Cloud. I've picked up the Terraform Cloud API token. And of course, right at that point, if we're detecting something, you should probably burn those credentials because they've already made it into Git and into GitHub. OK, let's see if we have any questions so far on the chat. Anything interesting, Kevin, that you've seen in the chat so far?
There's been a lot going on there, actually. My friend James Zabinski was asking about how you can expand or how CodeQL gets better over time. And then coincidentally, you had gone right into the CodeQL repo where folks can actually make contributions. So that was huge. Are you able to talk at all to the enhancement in the performance of CodeQL over time for different languages? I think James would be interested in that, and some other folks were asking about SonarQube, just FYI.
Yeah, definitely. So that's actually something that we work on very, we've been working on specifically this quarter, is to improve the performance of CodeQL, to improve how fast it runs within your build environment. It's important to note, though, that this is a very deep analysis, and we'd rather it take a little longer and not produce as much false positives for the developer. Because what ends up happening is if you give the developer too many false positives, they'll just throw out the entire tool. This is what we've seen in general. And so we are very much focused on weeding out a lot of that, and sometimes that does take a couple of extra minutes in order to do so. But it's important to know that we have been working on performance just in general in GitHub in order to make sure that it's as quick as possible. Going back to that Sonar question, yeah, I mean, you could definitely integrate SonarQube, right? Like anything that produces serif format, you can integrate directly within GitHub. So usually most of the SaaS vendors support that standard. So as long as they do, you just upload it into GitHub. There's a REST API for that, and you can start to view that directly within the GitHub UI. Going back to that, set up more security tools, right? Like there are a bunch of GitHub actions that you can use that have already been created, so that already have that integration built in. So you can check that out as well. Over to you, Kevin.
All right, I felt like a little bit of a gunslinger there on the chat, so I hope you don't mind, Mr. Isaac, just monitoring that while I am sharing some content. All right, so I'm going to go ahead and share my screen here, and we can get rocking. So what I'm going to be talking through with you today is really our supply chain security capabilities, and I want to help articulate how GitHub differentiates ourselves really across all the services on the platform, but specifically today, I think application security is going to be the focus. And one of the ways we do that in our advisory database, which is the home of all the security advisories that we aggregate from the National Vulnerability Database, partnerships with other security vendors, and most interestingly, and James Zabinski, I saw you in the chat here, so I'm going to call you out if I can. Most interestingly, we actually partner with the open source community maintainers themselves. And so you can imagine this massive community being on the platform. I think there's something like 50 million developers plus on the platform today, many of which are actually doing open source maintenance of their projects. And so if a security researcher comes along to the repository and says, hey, I found this vulnerability in your project, you should probably patch that, right? Or they stumble upon it themselves and want to issue a patch and an update to anybody who's consuming that package. What they'll do is they'll actually create an advisory. There's a private workflow for them to create an advisory, and that'll get handed off to a team at GitHub who will curate that advisory and then actually publish it back into the GitHub advisory database. And so why does that matter? How is it kind of different from any of the other tools, and why is it so exciting? Because you can imagine that it would be so difficult for GitHub to properly staff a security research team to meet the scale that's necessary for the entire open source community. And so a lot of this data it's crowdsourced by people like you who are actually maintaining these open source repositories. And if you're not and you're just kind of consumer of that, there's also another workflow we're going to be talking through. So one of the interesting things that we do, if you allow us to do so, is as you're storing your source code inside a repository on GitHub, we will basically scaffold out and give you this graph of dependencies that your application consumes. That's your direct dependencies and also your indirect dependencies. And so a good illustration of like what the ratio is of direct dependencies to indirect dependencies, think of an iceberg where it's 80-20, right? 20% of your dependencies are direct and 80% of them are actually indirect. And a vulnerability in one of your indirect dependencies can bubble up to your application, right? And so what's really interesting is the combination of us having this massive advisory database, right, with all these alerts for any packages that have vulnerabilities, and then us having the understanding of your source code when we scan your manifest file, what packages you're actually consuming. And so if you bring those two things together, what we at GitHub do with that data is we send these alerts. And we send them in a few ways. We send them through the UI, through the CLI, and through a command line. And so we'll basically say, hey, you have a package in your application. It has a known vulnerability in it. You're consuming it at this version. You should probably bump to another version. And so those alerts, if you haven't enabled it today, I always tell the folks that I work with at our customers, it's a super low hanging fruit. You can go to the organization level of your, or you can go to the org level as an org admin and enable these Dependabot alerts is what the feature is called. And so all your repositories will start receiving these alerts for packages that they're consuming in their primary branches that have known vulnerabilities. And so I'm gonna walk us through the workflow of landing in the advisory database, how we map that back to your repositories that are consuming that package, and what the remediation workflow looks like actually using Dependabot alerts and automated updates. And so speaking of automated updates, the reality is if you're like me and you've been doing development for some time and sometimes the work that you do is in the command line almost exclusively, you get these little notifications in the CLI that say, hey, your packages have known vulnerabilities and it's super severe. And you kind of just, your responsibility as a developer, or in the past, it felt like our responsibility was just to focus on delivering features. Right. And so I kind of ignored those things. And, what we found is that most folks actually do ignore those. And so it's not an anomaly to have a severe vulnerability through one of your open source components that you just don't patch as a developer because, either it's just too high a friction. You have other things that you would consider to be your primary responsibility. And so that's what we're here to talk about. Right. That is DevSecOps. And so we've introduced this feature called Dependabot security updates. And basically what that does is it takes that alert to the next level, okay? So not only will you see at the repository level, in the CLI, and via email, when you have vulnerabilities in your packages, we'll also leverage Dependabot to automatically open a pull request on your repository to patch that vulnerability for you. So something that's really interesting here, and actually this illustration is not a great example because it doesn't actually give you the compatibility score. But that's a really important piece of functionality, because where we source this compatibility score, which is really a probability of regression in your application, in some ways you can interpret it as that. The compatibility score basically comes from us opening the same pull request across the open source community and how many status checks actually pass after we've opened that pull request. And so basically, if we open it 100,000 times, and most of the times, 90% of the time, status checks pass after we've opened that pull request, and we can say that there's a 90% compatibility score. And so that's just another example of how the data on the platform, the open source community, comes back to add value in your own, in your own enterprise workflows. One other thing that I'll touch on here that I was having a conversation earlier today with another customer. Maybe that customer is on here. If so, hello. So this customer had actually brought up Dependabot version updates, and they were basically saying, okay, if I have all these pipelines across my repositories of my organization, how do I ensure that the actions that I'm consuming are up to date and not introducing a vulnerability or becoming deprecated at the version I'm consuming them? And so Dependabot will now not only patch your open source vulnerabilities, but it's also going to look to see whether or not any of the actions that you're consuming at the versions you're consuming them need to be updated. And if they do, of course, we will, we're going to enable you to automatically update them, which is super exciting. And so when I was talking about, how long it actually takes your typical developer who gets, who's notified, rather, just alerted to some open source vulnerability, it's 180 days. That's the mean time to remediation with just an alert inside your workflow. But that's reduced to 40 days for repos with Dependabot security updates. And so again, I would encourage you, if there's one easy takeaway, if you're like me and it's Friday and it's kind of beer o'clock soon, and it's on the I'm on the East Coast here. A lot of us are in India and all over the world. But the idea is, if you want to take one thing away, I'd encourage you to explore Dependabot. You enable at the organization level, and in this way, you have some baseline for the open source security of your applications. And so this would enable you to have 80% reduction in the mean time to remediation versus the industry norm. It's pretty powerful. Now, something that we always kind of bucket as part of the same conversation when we're talking about advanced security is these SCA capabilities, right? Software composition analysis. But what we don't really directly address in some cases when we have these conversations, we say, we talk about Dependabot, and the reality is that everyone on GitHub has access to Dependabot, including that alerts functionality and the automated updates. Now, what we are starting to do as GitHub, especially in the enterprise space, is layer on additional functionality to Dependabot in order to add additional value, right? So in this case, dependency review is one of the features that we've recently shipped that basically takes that scan that Dependabot has been doing on your manifest file in your primary branch or a branch that you've defined in your configuration file, and it moves that to your pull request. And so you can imagine a world where, rather than having to merge your change where you're introducing some open source vulnerability, we'll catch that as part of the open source workflow, and we'll bubble that up so you can have a conversation about it in the most natural place to have that conversation, right? Which is the pull request. So with that being said, let's go ahead and jump into a little demo together, and we can explore the advisory database and look at what that workflow is. So I've already gone and filtered the advisory database based on some CVE ID. And so if I'm looking for a specific CVE, I might just drop that in here. We find that there's one open advisory. I'm just going to go ahead and share the link here so you can actually follow along in the chat. I'm going to share it in two places, on LinkedIn, and I'm going to share it on the InFocus site. So here we go. Let's actually dive into one of these CVEs. And so the advisory database lets me know, hey, there's this package, fstream for file stream. It's an NPM package. It has effective versions. Anything less than this version, here's a patch version. And it makes me vulnerable to arbitrary file overwrite. Okay, should I care about this? And the answer is really here in my Dependabot alerts, right? And so you can see this tab here from the advisory database where it shows me that I have 15 open alerts for this specific vulnerability. So I'm going to scroll down, and what you'll start to see is my organizations and any repositories in that organization or organizations that have been impacted. So I'm going to scroll down to a specific repository to show you a specific workflow. But so here we go. Here's Octodemo organization in this repository, Demo Vulnerabilities GAS, GHAS. So where it takes me, this is hopefully a familiar interface for you. If you do your development in GitHub, it probably is. This is the repo landing page, but I've gone over to the security tab. And so you should have this same interface in dark mode, of course. If you go to the security tab, you should see your Dependabot alerts there. Maybe you don't have code scanning and secret scanning enabled yet. I'd encourage you to explore that, but Dependabot should definitely be enabled. And so if I have some vulnerability, it's going to show up here, right? Basically, what we can see is there's a recommendation to upgrade this package to version 1.0.12 or later, for example, and it gives me an example of how to do that. And then it links me back to the CVE. And so this is a circular experience, because if I click on this hyperlink, it'll take me back to that advisory database we were just exploring a moment ago. So rather than doing that, what I'm going to do is I'm just going to show you how we automatically open this pull request. And so what you'll see is Dependabot here. It's probably a little small for you, but Dependabot opened this pull request for us. I'm going to go there. We'll see that this pull request has been opened. There's a compatibility score, which means that this is 97% compatible. We talked about where that score is sourced from. There's also, if you're looking for more context about that, there's documentation on where that comes from. Something I like to talk about, because we're the home of the open source community, is how you can actually trace these patches back to the commits themselves. And so you can actually click here to drill down to the package, where you'll see the open source maintainer, or the team who maintains the package, actually patch that. And so if I'm just going to scroll down for a moment, I just want to demonstrate really fast how you'll also have your other checks as part of the same workflow. So you can have your CI here, you can have your additional SAST, as Isaac was showing us earlier. All your checks are going to be integrated into the PR workflow. And so as soon as you've validated that you have not introduced a regression, you can go ahead and merge this back into whatever your primary branch is. So one other feature that I'd like to share with you is the last one, which was reviewing your dependency vulnerabilities in your pull request workflow. So here I am in my pull request. I'm just going to scroll down for a moment to review dependencies pull request, which Mr. Isaac opened as well. So I'm just going to give you a thumbs up right there, my friend. Okay, so I'm going to go into the Files Change tab, and I'm going to look for my changes to my package JSON, which I happen to know, so I'll save you the pain of actually scrolling to the bottom. So what you'll see is there's some changes here in my package JSON, and this JSON logic.js package is being included at version 1.2.3. And what we don't know is that there's actually an alert out there for this package at this version that affects would affect our application rather. So if I click that, it takes me back to the advisory database. This has not been merged back to any primary branches, so there's no Dependabot alert necessarily, but we have some more information about that vulnerability and what the remediation path would be. So I'd encourage you, if you have Advanced Security, to obviously enable this feature. Make sure your Dependabot is enabled as well across your organization. And yeah, and that should set us in the right direction, I think, for software composition analysis. At least it'll set a nice baseline. I think Isaac pointed to something earlier, which was really interesting, is in that security tab, the integration experience. And I think we had folks asking about this a little early on, which was what tools have pre-built integrations back into Advanced Security. And so I'd encourage you to come into your code scanning tab and explore those pipelines available from the marketplace. Of course, you can also just go to github.com/marketplace to find things like the SonarQube integration, for example, and other SCA tools, or whatever tool it is that you're looking to integrate to your AppSec workflow. So with that being said, I think that's primarily what I had to share with you all. Just a quick one today. Any comments or questions bubbling up in the chat, Mr. Isaac?
Yeah, Kevin, I think we have a couple. One was on, can you just show that CI automatically running with the Dependabot again?
Sure.
When you open up a pull request, and that shows the CI running.
Okay. Yep. It's going to open any PR. It doesn't have to be that one, but
yeah, exactly. And that's that point of when Dependabot actually opens up a pull request, you're still able to run your CI in order to ensure that it's going to be compatible with the with your code base as well. Sorry, that was a question that was asked. There's another question about, do we envision Dependabot and CodeQL sort of merging together at all in order to figure out if we're actually using, if we're actually vulnerable to this open source dependency issue? Kevin, would you like to comment on that?
So I think so I don't have the exact phraseology down of what we're calling that feature. What I can tell you is that, yes, there will be a deeper level analysis that we do in the future. Just for the folks who are curious about that question or whether or not it's relevant for you, the point is that the way SCA in a lot of cases is done today is it's fairly primitive, right? We say, hey, you're consuming a package that has a known vulnerability in your application, and therefore you're vulnerable. But there's not a deeper analysis that happens, right? So we don't actually say, hey, not only are you consuming this package, but you're actually invoking the function in a way that makes your application vulnerable. And so there's that additional layer of insight that we will be providing to you in the future. At least that is the plan. Mr. Isaac, anything to add?
Agreed. So I would stay tuned for that. That's definitely stuff that we are thinking about today. One other question, Kevin. Do you have any information about the visibility and the roles and the permissions in order for security folks to see these issues within like repositories and whatnot? Like what permission do you actually need in order to see these vulnerabilities? So
I think, you'll have to keep me honest here, and there's different levels of permissions because there's different levels of functionality that you'll need as either, a developer who is a stakeholder in security now in this case, and also someone who just manages or is a part of the AppSec team, right? And so the reality is that every developer in the org, or at least that's what we're talking about with DevSecOps, every developer in the org is a stakeholder in the security of the applications they're building. Right? And so everyone with write access should have visibility into whether or not any contributions that them or their team is making are actually introducing application level vulnerabilities, right? And so if you have write access to a repository, you should be able to see whether or not there are any alerts open from a SAST perspective. I think the other thing is that you're gonna want that top-down view if you're, maybe just like an engineering leader or like some AppSec stakeholder. you're going to want to have a top-down view across your organization. And so there is a piece of functionality to do that. I'm not going to steal Isaac's thunder. I think he's going to share that with us in a little while here. Anything to add there?
Definitely. So I'll be able to show you some of the functionality that will help with that as well. One question from GC. Are Dependabot issues prioritized? Can Sev 1s be clubbed into one PR or something like that? So can you prioritize different vulnerabilities?
So I'm surprised that you're handing that one off to me again, because I don't want to steal your thunder. But so I think you certainly can't. We see a lot of our customers, they prioritize a lot of things, right? Especially when we're having a conversation about an initial rollout of GitHub Advanced Security. They want to prioritize their most critical applications, right? And then with their most critical applications, they obviously want to prioritize their most critical vulnerabilities that their SaaS tools find. And so in order to do that, those vulnerabilities should be classified as a critical severity vulnerability, a high severity, medium, low, or right? Like, what is the classification for that vulnerability in terms of the risk that it has for your organization, the risk impact? So yes, I think that there are ways to prioritize. I think that what you're going to show very soon makes that pretty easy, because you can actually filter based on the severity of vulnerability. But yeah, I won't steal your thunder there, my friend.
Thank you so much, Kevin.
Great.
Okay, back to me. So we seem to be circling really a lot about around this question of how can I gain additional insight into what's actually going on in my repos, right? Like, I see a repository-centric view, but I now want to think about things like organization-level views and enterprise-level views. And so this is where we start to talk about Security Center. Now, I will note that some of this feature is not released yet. It's currently in progress. But to give you a visualization of where we are going right now, the first thing that we're starting off with is a repo by repo view of everything that's going on within your organization, right? So which repositories are the riskiest? Which repositories have the most code scanning alerts? Which ones have the most secret scanning alerts? Giving you that top level visibility in order to figure out now where should you be spending your time and where should you furthermore drill down in. Everything as part of Security Center, we wanted to make it very, very actionable as well, so that you're able to drill down to the repository, but view things from a higher level. We started with that, and then also moved into that space of trying to give you the ability to see where these features are turned on as well, right? So are things enabled? Is Dependabot enabled? Is secret scanning enabled? The nice thing about secret scanning is the only thing that you really need to do is click that on button and you're done. But with code scanning, like, which ones are you actually getting results from? Which repositories are you actually enabled on? So hopefully this answers some of those questions around permissions, right? Like, this is the first foray into those higher level visualizations, which you can come to expect in the future, many more of these visualizations happening on the org and the enterprise level. That's really it from my side. I know that we have about 10 minutes left, so who has any questions? We'd be happy to address them now. Looks like we got one from Anthony Robertson. How do you manage org-wide policies that would enforce that Dependabot issues with the confidence must be completed before you are able to merge? We have hundreds of repos, right? So this is a very common issue. We have hundreds of repos. How do we actually manage that from an organization-wide policy? So today, policies are defined on the repository level, right? So you have the repository level. You can create checks on the repo level and whatnot. Now, you do always have the API in order to create some sort of org-wide policy in that manner. But in the future, I would expect to start to see things like an org level policy being dictated. Of course, we're not there yet. So in general, I would say run this on your repository level, or use the API in order to automate a lot of those tasks which are available today.
Hey, so I did see a question come up there from Scott as well, just regarding a little bit more granular roles. So there's been some folks who've been asking about an application security role. There's also been folks asking about, like, what about some sort of build manager role? And so I'm happy to talk about that. I don't know what your level of familiarity is with that, Isaac.
Go for it, Kevin, and I can fill in as well.
Okay. So so on our public roadmap, I'd encourage you to explore that. Maybe we can drop a link here for you. There is a description of custom roles. And so with custom roles, you'll be able to define specific authorizations for the roles for your organization. So you can imagine a world where you create some AppSec role at the org level, and then you can assign that AppSec role to some team or users. And the AppSec role provides authorization to do things like, view the security alerts or view the advisories that are open for your organization. So I guess my response is that the most compelling answer for you is stay tuned. Coming soon, we're going to have custom roles, and I think that's going to capture, if not in the initial release, definitely later on, a lot of what you would hope to see. So, is that fair, Isaac? I know it's very non-committal, but I'm a master of non-commitment. Ask my wife.
Stay tuned for custom roles. That's exactly what you're looking for. That will give you the ability to, for example, view vulnerability alerts without actually, having write access to a repository. Right? You'll be able to get very granular over there. I'm seeing a question from Matthew Henry. Is there reporting available for findings, MTTR, and other key facts that help drive down accountability on vulnerabilities? Expect some of those features to be built into Security Center. So we're not there yet, but that's definitely on our minds. Oh, thank you, Kevin, for dropping in the roadmap issue. Yep. So you can track the roadmap issue for custom roles right over there in our public roadmap. What else do we have in chat? Get in your questions, folks. Anything else?
Do you think we did justice to the integration experience? So folks who are not using GitHub's native CodeQL, what that is like to actually, because I know you had mentioned Seraph, and I think you touched on it for a moment. Is there anything more that we can say there? Someone else was asking about SonarQube, but funny enough is it's actually not available as a pre-built integration in the setup more code scanning tools. So I don't know if that's something we can touch on.
Yeah, definitely. So for tools that don't have a direct integration, like a direct GitHub action, which makes your life easy, right? Like at that point, you don't have to do anything. You just click on that button and it sets everything else. For tools like that, most SaaS tools support this Seraph standard, right? So you export all your results into Seraph. Then you really just have to use the API in order to upload that file so that GitHub knows about it. So usually as part of your CI, you'll run your build. You'll also run a security scan. That security scan will generate a Seraph result. Then you use the GitHub API in order to upload that Seraph result. And those results then will be visible within GitHub itself. Now that's a big thing for a lot of developers who are not used to seeing those results within their GitHub native UI. They have to go to some other portal and whatnot. And so not only having CodeQL, but CodeQL side by side with any linters that you may be using or any other external tools that you may be using is very, very interesting for a lot of developers today. I see Scott is commenting, says Seraph standard is very, very interesting to those of us that tools that fit the purpose to close the gaps. Exactly, right? Seraph provides that glue for different SaaS tools to talk to each other. Okay, I think that's all for today. Sean, would you like to end off?
Hey, Isaac. Hey, Kevin. So, hey, thank you guys again. That was awesome. So, with that being said, what a week we've had, right, folks? We've just concluded the last of 12 GitHub in Focus sessions. 12 sessions were covered. Topics were around the developer experience, DevOps, and security. We spoke with industry experts and got an inside look on how companies like Comcast, VMware, and Eli Lilly are putting the developers front and center in their DevOps and DevSecOps programs. And finally, you got to see the tool developers are using in GitHub every day to make their lives easier. You may not have been able to join us for all the sessions over the past couple of weeks, but don't worry. You can actually view all of the sessions that we've had by going to infocus.github.com. I want to thank you all for your attendance, participation, and insights over the last few weeks. We've learned a lot, and we hope you have too. But finally, before I wrap up here, folks, as I mentioned earlier, if you'd like to have a deeper conversation with some of our security experts here at GitHub, please don't forget to hit the book a meeting button on the right-hand side, and someone will be in touch with you shortly. And last but not least, we want to hear what you guys thought about all of the sessions that we've had over the past couple of weeks. So please take your time. Take the time and fill out the survey. You can click the button here on the right. There's also a QR code that should be on screen right now. You can scan that as well. And with that, I'd like to thank you guys again for joining us for an incredible 3 weeks. We look forward to seeing you soon on the next GitHub in Focus session.